Okay, so it's now on. All right, so let me bring this PowerPoint up. Did you guys get it? Did you get it in your email through Nearpod?
Yes.
So guys, when you open Nearpod, are you taking notes? Because Nearpod lets you do that. And then you can download your notes. Did you know that? Well, if you didn't do it, if you didn't know it, you can, copy your, just type down your notes, and then you can download that to your computer. You can save that. Okay. Okay. So like I said before, we're gonna see today, Module 2, Compute Azure Services, and then these are the learning objectives of this class today. Number one, we're gonna understand and describe core Azure architectural components. And we're going to understand and describe core Azure services and products. We will understand and describe Azure solutions. And we will understand and describe Azure management tools. Okay? And probably when you see management tools, you may wonder what that is. And believe me, you've already been using that. You've been using that in class, okay, without knowing. All right, so core Azure architectural components. So regions. This is something that Azure and other cloud providers have. Okay, this is not something typical Azure only. Okay, and this is nothing else than a geographical location, okay, that Azure has. As you can see here, there are over 60 regions in the entire world, representing 140 countries, okay? So going back to the question that Florentina asked me, if I needed 2 cloud providers, if I'm able to have, or to be able to use 60 regions with only 1 cloud provider, I don't need another cloud provider. With 1 is enough. All right. So as you can see here, Azure has more regions than AWS. AWS has like 24 regions in the entire world. Azure has 60 and more than that. Okay. So what is a region? A region represents a collection of data centers. So in every region, there are a lot of data centers, okay, which is where your data resides, right? So even though you are in the cloud, your data is in a physical server, okay, which is in a data center, okay? Now, be cautious about regions because you may be asked about regions in your exam. Okay, regions is super important, especially for disaster recovery. That's super important, okay? The more region your infrastructure is in, the more highly available you're gonna be, okay? So a region provides flexibility and scale. So you can be flexible, have your data replicated in different regions and be able to scale up, okay? And scaling when it comes to applications is that the application is capable of growing, right? It's capable of growing based on demand. That's super important. Whenever you create an application or software, it has to leave room for scalability. It has to be able to grow because things change, requirements change, and customers, they ask for more features and more features and more features. So your application has to be scalable. Now, once you create your application, then you have to be able, or you have to create it, just deploy it in a way that it's going to be up and running at all times with minimal downtime. Okay. Now, this preserves data residency, of course, because when you have two regions or inside regions, you have different data centers, right? And your data may be in different data centers. So when one data center is down, then the others will, keep the data, safe, and the application can still run. Okay, that's very important. The problem is that when you have only one region and then that region goes down entirely, then you are, in a bad position. So it's good to have two regions for disaster recovery. Okay. Now select regions to your users. That's super important because the closer the data is to your users, the lower the latency is going to be. And low latency is represents happy customers. So that's super important. If you are here in the United States, so you better choose this central US or West US or South Central US. Any these regions, the government regions is for government institutions, but you still have like this, normal, just to put it that way, normal regions. And if you are in Canada, for example, you can use Canada Central, Canada East, this, whatever is closer to your users. That's very important. Be aware of region deployment availability. So not all regions have availability zones, and not all availability zones have the services that you are trying to use. So that's very important. You have to become familiar with the region, become familiar with the availability zones and the services that are being deployed, that can be deployed in that region. So that's super important, and the cost is not going to be the same. So you have to be aware of that. Okay. There are global services that are region independent. They're like the content delivery network, traffic manager. Those guys, they don't depend on a region. Okay, but when you have more dependent services like a virtual machine, like a resource group, like a network, then you have to use a region. So they are region dependent. And then we continue. So Azure has this concept of region pairs. Okay, so there are regions that have a specific pair. Like this one, North Central US is paired with South Central US, and it makes sense because they're putting that the opposite points, right? North and South, East and West, West and West. But this is Central US and this is US too. This is East to, and this is Central US, Canada Central, Canada East, North Europe, West Europe. Different points, cardinal points. So the intention of this, the intention behind this is for disaster recovery. Okay, so you can have a pair, and when North is down, then you can use South. Okay, so Azure region is paired with another region. Azure prefers at least 300 miles of separation. Why? To be able to keep the data centers running. Because for example, there's an earthquake. An earthquake may expand, miles and miles. So if you have a data center that is 20 miles away from another data center, that might be a problem because the earthquake can be so big that it may affect both data centers. So it's better to play safe here, and have 300 miles apart. So that will guarantee that if one region goes down because of a disaster or something, the other one is so isolated, so away, so far from that region that still you can use it to recover. Okay, so some services provide automatic replication to the pair region. So there's some services that have native replication, automatically. They have natively. That's what it means, that it replicates automatically. But the other services that you have to replicate them, not manually, but you have to configure that. You have to choose that feature. Okay, so in an outage, recover of one region is prioritized out of every pair. So recover of this region, the priority is to fail over to this one. Okay, that's the priority, the pair. So the one that is paired, there's some connection between them. So that's the one that it defaults to in case of disaster, right? So Azure system updates are rolled out to paired regions sequentially, not at the same time. Okay, this is sequentially. If there's an update here, then it is, asynchronously. It's not synchronously. So synchronous means that the update happens simultaneously at the same time. But in this case, the updates are sequentially. Okay, so it's little by little and not at the same time. Okay, but still that region, the one that is not being used, the one that is ready for failover, is going to be updated at any point. Okay, so geographies, discrete markets that preserve data residency and compliance boundaries. So typically contain 2 or more regions. Okay, so don't forget that the term geography, it encompasses 1 or 2 or more regions. I'm sorry. Okay, and allow customers with specific data residency and compliance needs to keep their data and applications in close proximity. Proximity is very important. Like I said before, latency, low latency is the ultimate goal of every business. You don't want your customers to be unhappy and lose them. You don't want that. Okay, so categorized as Americas, Europe, Asia Pacific, Middle East, and Africa. So let's see this guy as something bigger than regions. Okay, so let's see that this is the biggest guy, and then we have regions, and then you have availability zones, and then you have data centers. So that's the way from the biggest to the smallest. Okay, geographies, regions, availability zones, and data centers. Okay, so there's a list of geography locations that I want to show you guys. Okay, I want to copy this and then come here. One moment. Okay. So I want to come here and just find the Azure geography that meets your needs, get all the information you need to get started in Azure in the geography that best fits your needs, from compliance to resiliency features. Select an Azure geography using the drop-down menu and compare the other geography nearby. So we have here the geography right here. So we can have these guys here, right? This is the United States. We have a region here, Central US, East US, East US to North. And then you have the location here is in Iowa, Virginia, Illinois, Texas. Year open. This is the year when it was first open. As you can see, South Central is the oldest one here. You see, yeah, South Central is the older one, and then AWS is North Virginia. There's always one region that is the oldest one, and usually the oldest one is the one that has the most services. Okay, because it's the oldest one. So this one has 3 availability zones. It was 3 nearest region with zone coming soon, South Central, available in 2020. Okay, so this one doesn't have any availability zones yet. This one doesn't have any availability zones either in 2021, available in 3 zones. So as you can see, you have to be aware that some regions don't have availability zones yet. Availability zones is very important for high availability. That's super important. I'm gonna put the link here in the chat. Okay. So we continue. Any questions? Yes, no, maybe. So next slide. So we have here availability options. Remember when we created, let me see here, portal. Let me go to my Azure account. Okay, so let me sign out here. I want to use this guy. So let me see how much money I have here, because you have to be aware of that all the time. Oh, 189. So I've spent $11 so far. Okay. Always check your balance. Okay. That's very important. You're not going to be charged, but at least you have an idea of what you are using. So 189 is what I have left here. Okay. And it's loading here. It's going to show me what services are running here. Okay. But that's not what I want right now. But it told me here that I spent $10.91. Okay. And then I can see here the details. I'm going to see here the service, service name. Okay. Show me. Storage 595, virtual machines 473, virtual network 23 cents, and subscription 1091. That's the total. And then the region, US East, $7.41, and then $3.50 in US East 2. This is amazing. I've used this only for 2 days and already have a balance of $11. That's ridiculous. Okay. So when I created virtual machine, I can come here to virtual machines and I create one. Let me delete the ones because I don't want to have it here. This is, I'm being charged for that. I'm not using it. If I create a virtual machine here, there's one section that I have to choose the availability options right here, right? So I have two guys to select from, availability zone or availability set. Don't forget that this guy, availability set, has a service level agreement of 99.95. It means that, your service is going to be 99.95% available of 100%. And availability zone has 99.99. Okay, so that's the difference. This is more highly available than availability sets. Okay, so we have here availability options. Okay, here we have a single VM. The VM service level agreement is 99.9% with premium storage. So whenever we choose the storage, okay, right here. No, this is the image. This one here, right? So I can check here, select the size, and then I can see all sizes here. But this is the family. I'm talking about the premium disk, something like that, which is supported, not supported. Okay, whenever it's premium, you're gonna have this guy here, this availability, this service level agreement. Okay, 99.9. Okay. Now availability sets, like I said before, they protect against failures within data centers. Okay, that's the main objective or goal of availability sets, to protect against failures within data centers. And the service level agreement is 99.95. Okay, now we have availability zones. So in this case, we have more availability here, right? And that's why the service level agreement is going to be 99.99%. So what is the objective of this? Protection from the entire data center failures. Okay, so if you had that question in mind, and then probably you were wondering, what's the difference between availability zones and availability sets? Well, first, the service level agreement for the availability set is 99.95, and for the availability zoned is 99.99. Also, another difference is that availability set is for failures within data centers, right? Within data center, inside the data center. And this is the failure from the entire data center, okay? So it's a little more, more encompassing, a little bigger when it comes to availability zones, okay? And you don't create the availability zone. That's already created for you. You create the availability sets, and then you can put the virtual machines there. And it's very important when you create a load balancer that you can balance the traffic of those availability virtual machines when they are in an availability set. That's very important, okay? So when I create the virtual machine, right? I can put that one in availability sets. I think I don't have any, so I can create it here, right? And then I can call it my availability sets, just mass. 2 full domains and 5 update domains. We're gonna see that when we get there. So I can create this. Now, if I choose availability zone, that's already created for me. So 1, 2, and 3. I can choose this availability zone. Okay. Now, when you have multi-region disaster recovery, region pairs regional protection within data residency boundaries. So here we have region 1. Let's say that we have North Central US, the first region, and then I have a pair, South Central US, right here. Okay, North Central, South Central, just an example. And then this one is going to be standby for failover, disaster recovery. And then this was going to be, active and passive. Okay, so that's going to be active, passive. Right. Now, availability sets, you keep the application online during maintenance or hardware failure. Okay, so this comes handy when you have to update your applications, right? Or you have to maintain them, or you have to install, or something, or there's a failure in that. So there you can schedule maintenance, performance, or security updates in a sequence through update domains. So you can use this guy whenever you have to do any modification or an update to your applications, right? So you have the update domain here, whatever you say, UD is update domain. UD1, UD2, so you're using these 3, right, for updating your application. And the default domain, which is FD, FD0, FD1, FD2, is to provide a physical separation workloads across different hardware in a data center. Okay, this is for fault tolerance, right? To keep your application running. This is a little different concept when it comes between AWS and Azure. AWS doesn't use availability sets, but Azure does. And inside availability sets, we have update domain and fault domain. What is the default update domain? We can see here when we create an availability sets. Okay, if I create 1, what is the default one? 2, right? And what is the default one for update domains? 5. So we can have the update domain count is 1 when the default domain count is 1. Okay, what is the biggest one you can have? 3, right? So 2 is the default one, 3 is the biggest one. So remember this, because in the exam they may ask you, right? So the default for update domains is 5, and the biggest one is 20. Okay, default is 5, highest is 20. Okay. Right. Availability zones, physically separated locations within an Azure region. Data centers are in an availability zone. Okay, so you have, like I said before, geographies, regions. Like a geography contains a region. A region contains one or more data centers, which is, I'm sorry, a region contains an availability zone. An availability zone contains one or more data centers. All right. So it takes availability sets to the next level. Of course, it's more available than availability sets. It includes one or more data centers equipped with independent power, cooling, and networking. So everything that is created here in the region is created with failure in mind. Okay? Like someone once said, everything fails, so we have to design for failure. That's very important. Before we do anything, we have to create something that is ready to continue running when something fails. So we have to think about that, because if it fails and there's no way in this world to recover, we are doomed. So we have to create something. We have to do something. Like I said before, happy customer, happy business. Your customers are not happy, bye-bye. You have to go, no more business, because the customers that ultimately are the ones that, you know, maintain your business. If you don't have customers, you don't make money. If you don't make money, you cannot sustain a business. All right. So it adds an isolation boundary. They're isolated from each other. Data centers are like 3 miles apart. The data center is inside an availability zone. So, then you can draw a conclusion that an availability zone is separated from another availability zone like 300 miles apart. Okay. So if one availability zone goes down, the other continues working. That's when you put your services in more than one availability zone. If you put it only one, you have a problem. Okay, if the entire AZ goes down. Okay, so you should have at least two, right? At least two. If you have three, it's much better. But the more you have, the more you pay. Don't forget that. Okay. Resource groups, containers for multiple resources, right? We got a resource group here that, harbors a web server, a database, a virtual machine, and a storage account. You can have that in one group, okay? Or you can have web and DB resource group, virtual machine resource group, storage resource group. It's just a matter of organization, how you want to organize your services, okay? It aggregates resources into a single management unit. Of course, if you want to delete the entire thing, you don't have to delete one by one. I don't have to delete my web server, my virtual machine one by one. I can just delete the resource group as a unit, right? And that's it, it's gone, right? So every Azure resource must exist in one and only one resource group. You cannot have or just pretend that you're gonna have a storage account in two different resources group. That doesn't exist, okay? It's only one. Now, how do you secure that resource group? You can use a role-based access control, RBAC. We saw that in class. I show you how to do it. Today, we're gonna do it again, but I'm not gonna do it. One of you is gonna do it. So, and if you don't know how to do it, it doesn't matter. You can step up and we can help you. Me and the other students that know. And if no student remembers, I can do it. I can help you, okay? So that's how you secure your resource group, by putting all of them in one unit, and also using a role-based access control feature, right? Azure Resource Manager, also known as ARM, okay? It provides a management layer that enables you to create, update, and delete resources in your Azure subscription. Create, configure, manage, and delete resources and resource groups, organize resources, control access and resources, and automate using different tools and SDKs. So if you put here RM, Azure Resource gives you an overview here how it works. What is Azure Resource Manager? It's a deployment and management service for Azure. It provides a management layer that enables you to create, update, and delete resources in your Azure account. So this shows the role Azure Role Manager plays in handling Azure requests, Azure Portal, Azure PowerShell, Azure CLI, REST clients. This is how you create resources. This is the way, okay, through the portal, PowerShell, CLI. And then you can create resources with this guy. It's basically a template, right? When you create a resource, let's say that, let's see if it works with storage account. So I have a template here, you see? This is the template of my my Azure storage account, okay? I can save this guy. I can save this guy, add to the library. So I can call it my library. Okay. So I have this guy here, and let me see here. I got an error here. So if you remember CloudFormation in AWS, this is an equivalent in Azure. Okay, this is the Azure Resource Management template. Okay, so basically you can have the template and parameters. The parameters have this uses the type. This uses the values here and the type, and this one uses the parameters, right? So two files that you need to run your resources and deploy them again. You need the template and you need the parameters. Okay. Now you can create a script using the CLI and the PowerShell. If I click here, it shows me a script of how to run that. Okay. So basically, that's what the Azure Resource Manager is. Okay. Core Azure services and products. So Azure Compute. What is compute? When you think about compute, what is it? What is compute?
The power of your machine.
What you're using to run the machine, like CPU, memory, the OS, operating systems.
Okay, so everything that has to do with calculations, all that, that's a computer, right? Computer. So the word computer comes from compute because it works with numbers, you know? Now, compute is on-demand computing service for running cloud-based applications. It provides computer resources such as disks, processor, memory, networking, and operating systems. In other words, a computer, right? And whenever you see an appliance, anything that you see, anything, has a memory, has a CPU, has RAM, okay? You see, for example, the rice cooker. Do you think the rice cooker is a computer?
Yes, indeed.
Okay. So a rice cooker has a RAM, memory, has a CPU, all that. So that's compute, right? So it makes resources available in minutes or seconds. It all depends on how your connection is and how fast your computer is. Lots of on-demand services and pay-per-use. But we're talking about the cloud, the Azure cloud. So when you come here to the home section, and then you create a resource, and then you come here, what it says compute, then you're going to see all the compute services that Azure has. And there we see the virtual machines. We see the SQL Server 2017. We see the reserved VM instances, Kubernetes services as containers, service fabric cluster, web app for containers, function app, and batch services. Weird that it showed the image here. It shows that the image didn't load. Let's see if I refresh this and see the image there. Now I see it. Okay. So I see the DevOps started and storage account. So all of these are, and by the way, I was charged another $1. So I'm being charged by the minute. Okay. This is so expensive. Okay, not a problem. It's not my money. So these are the services that are in the compute category. Okay. Now, Azure VMs are infrastructure as a service. Remember, when they ask you what's an example of as infrastructure as a service, and VM is there, don't forget to choose VM. Okay. If they tell you choose one, VM is the answer. If they tell you choose two, VM is one of the answers. Be careful with the other answers. Okay. I gave you guys, I think it was on the first day or the second day, I gave you several documents that have examples of infrastructure as a service, platform as a service, and software as a service. So I'll go over that because you might be surprised in the exam, and I don't want you to be surprised, because most of the time when you are surprised, or we are surprised, we don't know what to answer. So we don't need to be surprised. All right. Also, VM scale sets. This is the same concept as auto scaling, right? Auto scaling in AWS. So they're designed for automatic scaling of identical VMs. Whenever you use a scale set, just like auto scaling, all the virtual machines that are created using scale sets are identical. And as they are identical, they are disposable easily. So if you need to remove one, it doesn't matter, just remove them. I cannot dispose of my computer right now. My computer, the one that I'm using for this class, I cannot, because this computer has important data that I don't want to lose. This is all my things, my job things, everything that I have for everything that I do is in my computer. So if I lose my computer, I may not lose everything because I may be smart enough to put everything in the cloud, just in case my computer, is off, not working anymore. But my computer is not disposable. I cannot, get rid of that just like that. But in the case of scale sets, every single computer, every single virtual machine that you create is exactly the same. So you can dispose of them and still you don't lose anything because you have a bunch of them, that have the same information. So they are disposable. App Services is a platform as a service, or PaaS, offering to build, deploy, and scale enterprise-grade web, mobile, and API apps. Okay, so we're going to see that App Services later. And then we have functions that perform compute actions based on an event. Okay, so when you think about functions, you think about Lambda. It's the same thing. Lambda is a trigger. It's a trigger function. It's an event trigger function. The same with functions, Azure functions in Azure. They have to be triggered by an event. All right, same thing. Now, before we continue, what time is it? Okay. When I finish this section, I want someone to create a virtual machine for me real quick. Okay. So we have container services. Containers are a virtualization environment. However, unlike virtual machines, you do not manage an operating system. Containers are meant to be lightweight and are designed to be created, scaled out, and stopped dynamically. So we have something called Azure Container Instances, which is platform as a service. So if I put here container instances, so you can create a container instance here. And of course, you have to just use a resource group in every single thing. Okay, so you can use a quick start image. It's like creating a virtual machine, but you're gonna run it in containers. So what is the advantage of running applications in container? Is that container is self-isolated. Okay, they're self-contained. They don't depend on other containers or other applications, and they are isolated. So that's pretty good. There's something that is very popular right now. It's called Docker. Is anyone here using Docker? Docker containers?
No, I'm
No.
not.
Docker is great, says Brian. Brian, can you elaborate on that? Why do you think that they're great?
Hello. Okay, cool. So it's essentially like a sort of delivery system for like software. So it's kind of like a package, kind of like in a container. So essentially all you do is it's isolated from everything else. So if you ever need to update a software, it doesn't need to update the entire thing. It will update whatever part of the container that part gets updated. So everything becomes compartmentalized. So you can actually run, let's say like Ubuntu on just a bare minimum of what you need to kind of do like an OS level virtualization of it. I don't really know how to explain it like in simple terms, but let me just tell you that it makes it really, really easy to kind of get software and applications to work together.
Good. Thank you, Brian. So Docker is a set of platform as a service, is PaaS products that use OS level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software libraries and configuration files. They can communicate with each other through well-defined channels. So the good thing about this is that they are isolated. Okay, they're not dependent on anything else. They don't depend on each other. So this is kind of like a little image of how containers work. You see, you have a virtual machine here, right? Virtual machine. You have application A, application B, application C, right? Guest operating system. You know, this is guest, right? This is not the main operating system. This is the guest one. Guest operating system, because that's a virtual machine, right? And guest operating system. So you have here containerized applications, right? They're each one is in the container. Application A, B, C, D, E, and F, and then you have a Docker container. Docker has containers, right? And then you have the host operating system, which is the operating system of your machine or whatever structure you have, and then you have the infrastructure, right? And on top of that, you have the Docker, and Docker has containers, okay? Which is pretty good. If this one is down, this one is not down. So they are isolated to each other. It makes your life so easy, but you need to understand containers, okay? And that's a different class, okay? So you can download this little application here. So a container, Docker container is like a whale. The icon is a whale. And by the way, I have it here running in my computer. Right? You can create a container account, right? Right here, one moment. So things that I you know, practicing all that, I created, and I have this guy here, you know, restart Docker desktop. And of course, Docker works with images, right? Containers, they run images. You have to have an image. There's something called Docker Hub that contain images for operating systems like Windows, Linux. I don't want to sign in. Okay. So I can say Windows, and I have an image here for Windows Server Core. I can have image information, internet information services, or maybe I can say Linux here, and I have an Ubuntu image here that I can use, right? I can use this guy here, and I can use this command to pull that image, right? Okay. And then with this image, I can run a container application. All right. So it's very, very useful to work with containers. So whenever you go, I mean, not whenever you go, most of the big companies use containers, Docker more specifically. When I worked for the College Board in Virginia, they were using Docker there. Okay. Actually, like I said, it's a whale. Okay. The icon is a whale. So you can create containers instances that allow you to upload your containers, which it then will run for you. It runs containers. So these instances, they run containers for you. Azure Kubernetes, that's a third-party container services, and AWS has it. It's Elastic Container Services, Elastic Kubernetes Services, EKS in AWS. In Azure is AKS, Azure Kubernetes Service. It's a container orchestrator service for managing large number of containers. So this is a third party. Kubernetes is a third party, but you know, in Azure you can use that third party to, you know, orchestrate a bunch of containers working together. Okay, you don't need to become an expert in these matters, just to know that an Azure container instance allows you to upload containers, and a Kubernetes is an orchestrator to run or manage a large number of containers. Azure Network Services. We saw this in class already, the Azure Virtual Network, right? And guys, let me see. Yeah. Guys, when I post something on the chat, are you taking note of that? Are you noting that? Are you copying that on the chat and pasting it somewhere?
Yes.
That's very important. Don't let that go. Okay. I'm gonna post this for computer services. Okay. I posted on the chat. I'm gonna post this for container services. Okay. I'm gonna post this for these guys here for computer services. I'm gonna post this Azure container instances and Kubernetes services. Okay. Let me put here container services. Okay. And then those guys. I'm gonna post this guys for I may create a text and a document later, but in the meantime you can save this to yourselves. Azure Network Services, right? And then I copy that. Okay, so in that category, we have the Azure Virtual Network provides secure communication between Azure resources. And if you have two different networks and you want those resources inside the network to communicate with each other, let's say that you have VNet 1 and VNet 2, and then you have a virtual machine in VNet 1 and a virtual machine in VNet 2. If you want them to communicate, you have to create something called VNet peering. You have to peer both networks, okay? And then when you peer both networks, you have to peer 1 to 2 and 2 to 1. It's not only one way. You have to do it both ways. 1 to 2 and 2 to 1, and then you'll be able to communicate with the resources inside each network and communicate with each other. Now, if you have a VNet 3 that is peer with VNet 2, it doesn't mean that VNet 3 and VNet 1 are going to be able to communicate. No, there's no transfer of peering here. If 1 is peer to 2 and 2 to 1, and then 2 is peer to 3 and 3 to 2, 1 is not peer to 3. You have to create an independent peer for those two. So 1 peer to 2, 2 peer to 1, 2 peer to 3, 3 peer to 2, 1 peer to 3, and 3 peer to 1. That's the only way, right?
That was so confusing.
It's like
no.
routing, right?
Okay, one moment. Just give me 1 second. Let me make clear for you. Okay. Let me see if I can use some graphic here. 1 moment. Maybe if I say that sounds confusing, but if I show you, 1 moment. Okay.
It's not you, Professor. It's not what you're saying or how you're saying it. I just think that maybe I'm getting lost in the overall, like the whole thing of how it's all coming together.
Yeah, I understand. So this is BNet 1, right? And this is BNet 2. Okay. And this is BNet 3. Okay. So let me give it a name. Okay. Right? So inside this VNet, you have a virtual machine. Let's say that this is a virtual machine. A little virtual machine.
That's a big machine.
That's the big machine, yes. Okay. This is a very shapeless machine. Okay, so you have a virtual machine here, a virtual machine here, right? And a virtual machine here, right? Okay. So we have 3 virtual machines. Now you want this VNet to communicate with this VNet, and then of course you want these virtual machines to communicate with each other. Okay. So what you have to do is do some peering. Okay. So we're going to do this, right? And then both virtual machines can communicate now. So you have peering. This one is peer with this one, and this one is peer with this one. Okay. Now, I want the virtual machine to be VNet 3 to communicate with VNet 2. So I can do the same thing. I can communicate. Just do this, right? And then B3 is peer to B2, and B2 is peer to B3. Now, the fact that these two are peered and these two are peer, it doesn't mean that this one is going to be peer to this one. There's no communication between these two. This will not be transferred to this. Okay, so I have to I have to make these two communicate as well. Okay, so there's no way that I can communicate like this and then this one will be communicating with this. All of them have to be peered, one to each other. Okay, for them to communicate.
Okay.
You got it now?
Thank you.
So how many peering can be done with one virtual network?
How many what?
How many different pairings can you have?
How many peering can be done with one virtual network?
Well, you need one, right?
No, but means how many you can
How
do
many
it?
VNets can you have then? That's what he's trying to say.
Oh, as many as you want. I mean, I can have another one.
Because in AWS, it was only one you can peer with one.
I can have another one here. And then communicate to this one.
And V1 also communicate with V4 if we connect.
No, that's what I'm saying.
If we connect.
But you can add a.
If we connect.
Yes, of course. But right now, V1 and V4 are not connected. So I have to do this.
Yeah, that's what was I asking, because I think in AWS, we cannot do this.
No, AWS is exactly the same concept.
It's the same thing.
Same concept.
Yeah, you just don't automatically connect the networks together. You have to manually basically do it.
Yeah, you have to peer them. Yeah. Same concept. That's what I've been telling you since the very beginning, guys. Azure, if you know AWS, Azure is going to be so simple for you because it's very similar. I wouldn't say it's exactly the same, but it's very similar. The concept behind this is the same. Okay. There you go. That's the concept. Okay, so we also have Azure Load Balancer automatically scales to, one moment. Scales to create highly available access to applications and resources. And as you know from other courses, load balancers, what they do is you just balance the traffic. They balance the traffic. So we may have something, something similar to this one. Let me remove this guy here. Okay, so I may have so I may have this guy here. I may have this virtual machine. Let me call it okay, this is VM1. I'm gonna remove this guy, make it better. Okay, so I'm gonna have VM1. Okay. VM2. VM3. And then VM4. So we have the 4 VMs here. So we're gonna have a guy here. Let me see what shape I can use for this guy. Let me use this guy here, probably. Let me use this guy here. So we're gonna have this guy here controlling the traffic, right? So whenever there's traffic coming in, this guy's gonna be the single point of entry. The traffic comes through this guy, and then it balances the traffic. It balances out the traffic, right? So it's gonna be sending traffic, evenly to all the virtual machines. So it's gonna be here, send the traffic to this one, right? And then to this one, right? To this one. And to this one. So it's gonna be sending traffic, all the traffic that's coming in, this guy here. Okay, the traffic is coming in there, and then this is the
You just put LB.
huh?
Just
You
put
could
L.
abbreviate it, just put LB.
I think everybody would
Yeah,
understand.
yeah. So LB, load balancer. Oh my God. Okay, so load balancer. Okay. Got it. So load balancer here, it's gonna be working here to distribute traffic evenly, and it's gonna be sending health checks, every now and then, depending on the interval they choose. You choose between heartbeats, and then it's gonna be sending health checks to each virtual machine to know if the virtual machine is healthy or not. Okay, and of course, if it doesn't show healthy, it would not send traffic anymore. Okay, so that's what happens. Okay. We have VN Gateway. It's a platform managed, scalable, and highly available application delivery controller. Okay, this is used for connecting from the on-premise to the cloud. Azure Application Gateway provides for the management of traffic at web applications. This is the other type of elastic load balancer for applications. In AWS, you have network load balancer, classic load balancer, and application load balancer. Here you have elastic the load balancer and the application gateway. This is for applications, right? And then you have the content delivery network, also known as CDN, that provides a distributed network of servers that efficiently deliver web content in their local region. So this is the one that delivers the content also for global delivery.
Is that
Okay.
the equivalent of CloudFront in AWS?
Correct. That's the guy. Okay. So in the Azure data categories, we have structured data, semi-structured data, and unstructured data. Okay. So structured data is those databases that are SQL. Okay. They have a schema, they are strict, they're less flexible. There's nothing you can do with the schema. You have to adhere to the schema. Okay. And the schema is the way that the database or the table is structured. Okay. It has the same data fields and properties. You cannot change the data field. If you change the data field, you change the entire data, the entire table. Okay. And the data relationships storeable in relational database tables. So there's relationship between database A and database B, right? So they have a relationship. They have rows and columns, right? It's like any database. If you open an Excel sheet, you're gonna see that it has rows and columns, right? That's how a database, a table in a structured database is, right? It has sensor data and financial data for some. That's an example, a sensor data or financial data, or any table that you see. Mostly, most of the tables that you see are relational databases. Okay. Now, semi-structured database it has an ad hoc schema. It has a schema with a purpose, okay, with less organized fields and properties. That's when NoSQL databases come in, okay? And this is what we saw in AWS, like, remember DynamoDB? DynamoDB was a NoSQL database, right? It has a semi-structured data, right? It has no way. I mean, you can change the schema, or actually it doesn't have a schema. It's very flexible, right? So one column can has 10, one row can have 10 columns, another row can have 5 columns. So is visibly, when you see it, you think this is a disaster, okay? Because we are so used to seeing structured data, a database, a table that is structured. It has a schema, 5 columns, 20 rows, and that's the way it is, right? As long as that table exists. But in the case of semi-structured, it says on some SQL database or table, it's non-relational. There's no relationship between tables. It's so chaotic, or apparently it's chaotic. It's not. That's the way it looks because we're not so used to seeing that. Okay. So in that case, we can have books, blocks, JSON. Usually, NoSQL databases, they have a format, and the format is JSON, JavaScript object notation, or it can be an HTML document. Okay. So guys, it's 7:55. Right, the time for the break. So take a break. Let's take 10 minutes break, and then we come back at 8:05. Okay. Gabriel, can you hear me? Okay, guys, we're back. So we were talking about semi-structured data, right? And then it has tables, rows, and columns. Examples that we have the books, the blocks, JSON, hot HTML documents. And then we have unstructured data. They don't have a designated schema, right? And they don't have a data structure. There's no relational block data with no restrictions and on the kinds of data blocks contain. Examples of that, we have PDFs, JPGs, videos, all that. That's not unstructured, right? You know. Now, Azure Store Services. So we have IaaS and PaaS. So we have as examples of IaaS, we have persistent disks in the disk section for Azure IAM VMs. We have premium storage, disk options, SSD based, high IOPS, input, output per second, low latency, lift and shift operations. And we also have files, SMB, you know, SMB, it's a protocol. A moment, it's a protocol. Let's see if I can find here. Okay. SMB is a network file sharing protocol that requires an open port on a computer or server to communicate with other systems. SMB ports are generally port numbers 139 and 445. So this is for file sharing in the network. Okay. And it stands for server message block. All right. Okay. You can access it from anywhere, and it's secure access. Okay. PaaS, we have containers, tables, and queues. So containers, unstructured data, text or binary. Okay. Blocks, block blobs, page blobs, append blobs. Tables, we have NoSQL data store, structured data. Dynamic scaling based on load. That's the scale sets. Scales to petabytes and data. Fast key value lookups. Queues, we have store and retrieve message, highly scalable. Messages can be processed asynchronously. So whenever you create, let me see here. Where's Azure? Did I delete Azure here? And then here, I can just put it inside this guy here, and then I can call it my other storage account, and then I can put here. It's already taken. Okay, so I'm gonna choose storage general purpose V2. Okay, that's the one that Azure recommends because it has more features than V1. Okay, so data protection, disable, okay, advanced tags, create and review, okay, pass validation, I just create, we're creating a Azure storage account. Let's wait for that. This one takes a little longer. So if I go to resource, I have something here because this is a general purpose, right? This is not a blob storage like the one that we created on Monday. On Monday, we created a blob storage that only had containers, right? This one is a general purpose, right? It has containers, file shares, tables, and queues. And that's exactly what we're seeing here in this particular slide, okay? Containers, tables, and queues. And the files too. The files are here, file share. Okay, so that's storage services. So we have this, which is what we use when we create a virtual machine, and we have file storage containers and tables and queues when we create a storage account. Okay. Think of this as S3 bucket in AWS and this as EFS, Elastic File System. Okay, in AWS, similar. You can share, share these files using the SMB storage managed block port 445 139. You share the files. Okay. So it has a built-in unified distributed storage system. It has durability, encryption at rest, strongly consistent replication, fault tolerance, and auto load balancing. So you can see all these features here in this storage services. Okay, so I'm gonna put in the chat the link to this, right? Okay, good. So in the Azure database services, we have CosmoDB. Okay, don't forget that's like DynamoDB, similar. It's a globally distributed multimodal NoSQL database service that enables you to elastically and independently scale throughput and storage. So whenever you see, guys, just keep this in mind. Whenever you see globally distributed multimodal NoSQL, that's Cosmos DB. Okay, that's a NoSQL database. That's the NoSQL database of Azure, Cosmos DB. Don't forget that. Globally distributed multimodal NoSQL database. Okay, very important. Now, when it comes to SQL database, relational database is when we see SQL databases. Okay, SQL servers. Okay, that's the Azure SQL database, which is a server, right? A database server, and it's known as DAAS, which is Database as a Service. Okay, and it's based on the latest stable version of the Microsoft SQL Server database engine. This is a very popular database engine. Even AWS uses it, right? When you use RDS in AWS, Relational Database Service, then you have one of the engines that is supported by RDS is SQL Server, okay? And that's an Azure and Microsoft service, right? We also have Azure Database Migration, which is used when you migrate from on-premises to the cloud, right? You migrate your database. It's a fully managed service designed to enable seamless migrations from multiple databases sources to Azure data platforms with minimal downtime. These are just a few of our database offerings. These just are the main databases in Azure, right? Services, the main database services. So don't forget the ones here. Cosmos DB is a globally distributed multimodal NoSQL database service, and we have Azure SQL database. It's a relational database, also known as the DAAS or Database as a Service, and also Azure Data Migration, which is a fully managed service that is used for migration of multiple database sources to Azure. Okay. So the Azure Marketplace is the place where you can sell, you can buy resources, right? It connects the end users, Microsoft partners, independent software vendors, and startups that offer solutions and Azure services, right? You can find Azure customers, IT professionals, and cloud developers. You can purchase, you can try, you can provision Azure applications and services from certified service providers. And it has almost 10,000 product listing. So does it ring the bell, guys? When you see Azure Marketplace, does it ring the bell?
Yes, AWS has its own market.
Yeah.
It does as well. Okay. Amazon also has its own marketplace. You know, if you're a seller in Amazon, you can have a marketplace too, so you can buy resources. I think it's a standard concept to have in your if you're a cloud provider, to have a marketplace where people can buy and sell resources. Let's say that you buy a service that you're not using anymore. So are you going to keep it? No. What are you going to do? You sell it, right? And of course, when you sell it, there's going to be another person who needs it, so it's going to buy it. Okay, that's the marketplace. Okay. So let's some more Azure solutions. So we have something that is very popular, Internet of Things, right? So these are just two of our of Azure IoT offerings. You use the IoT product selector to determine what product is best for your situation. Okay, I'm gonna put here the link to the product selector. I'm gonna put it in the chat. So that's gonna help you guys and whoever is trying to use Azure to determine what product is the best solution for them. Okay, I posted on the chat. Okay. For the IoT Central, right, it's a fully managed global IoT software as a service solution that makes it easy to connect, monitor, and manage your IoT assets at scale. So for that one, I'm gonna put a link as well in the chat. I hope you are getting these links, guys. Okay, let me put it here. IoT Central. And also for IoT Hub, I'm gonna paste another link there as well. So an IoT Hub, it's a managed service hosted in the cloud that acts as a central message hub for bi-directional communication between your IoT application and the devices it manages. Okay, so these are only two of the offerings, the IoT offerings. And if you want to determine which product is best for you, then you can use the product selector, the link that I just posted on Slack. Well, guys, this is just for your, just for you to know that it exists. You don't have to know about IoT for this exam. Is you have to know that you have the central and the hub. Okay, so try to remember, when you study on your own, try to remember what they're for. Okay, so I'm gonna paste another link that is a list of the IoT related services available with Azure, right? And also the context of when to use them, right? I'm gonna paste that here as well. Okay, that's a full list of IoT related services available with the Azure. And for context on when to use them, see the page that I just posted. Okay. Big data, very popular nowadays. Okay. So people are, there's a lot of companies that are using big data experts to just to handle and work with their data, you know, organize it, clean it, you know, filter it, all the things that you do with data. And it's a very popular specialty field nowadays. Lanis, did you get your big data already? Are you working on it?
Who are you talking to?
Sorry about that. No, not yet.
Not yet. Okay.
No.
Yeah, that's a good certification. That is a good certification to go for, guys, if you want to expand your knowledge. Big data is a good certification to go for nowadays. Very good certification. Okay. Either in AWS or Azure. Very important. That one and machine learning are very popular right now, on high demand. Okay. So here we have this Azure Synapse Analytics, formerly Azure SQL Data Warehouse. And does it sound familiar, guys? Does it sound familiar? Data Warehouse?
Yep.
Remember? Redshift?
Yep.
Redshift.
Yes, there you go. This is the guy. This is the guy. Synapse Analytics, right? Also known as, it was known before as a SQL Data Warehouse. It's a limitless, and also, Redshift has analytics features. It's a limitless analytics service that brings together enterprise data warehousing and big data analytics. So this guy has both warehousing and analytics. Okay, don't forget that. When you see analytics and big data, that's Azure Synapse. Okay, there's another one here, Azure HD Insight. It's a fully managed open source analytics service for enterprises. It's a cloud service that makes it easier, faster, and more cost-effective to process massive amounts of data. Okay. So I have here some links for these guys too. Guys, I hope you're copying these links because I have posted a lot of links today. Okay. Okay, so the other one was Data Lake Analytics, like AWS Data Lake. It's on-demand analytics job service that simplifies big data. Instead of deploying and tuning hardware, you write queries to transform your data and extract valuable insights. This is also known as ETL. ETL is extract, transform, and load data. It's like you have some data in a container, for example. In a container, you can use this service to extract the data from the container, right? You can transform the data, change the columns, the rows, you transform the data, and then you load the data back on a different container, right? And then you have in one container the data that is rough, the one that is not clean, transform, and another container you have the data that is already transformed and clean. Okay, so you can do this. ETL, don't forget that. Extract, transform, load. Okay. Artificial intelligence, very popular nowadays, also known as AI. Okay, Alexa. Who has Alexa here?
Everybody.
I think everybody, right? Have you guys ever tried to create an Alexa skill? Never?
No.
Never? I surprised my wife once. I created an Alexa skill because there's a developer website page, for developers in AWS. And then you can enter there, create an Alexa skill, right? Just write what you want Alexa to tell you when you ask a question. So you create the question and you create the text. And then when I got home, I asked Alexa, what can you tell me about Dunieski and Janet? And then Alexa said, Dunieski and Janet met 4 years ago in a place like this, that. And my wife was surprised that I was able to create an Alexa skill. You don't need to be a master, or you don't need to know any programming or any artificial intelligence. You just need to know where to go, and where to create the skill. That's it. It's very simple. And it's using a feature, it's speech to text, or text to speech, I'm sorry. And then Alexa will read it for you, okay? It doesn't support Spanish yet, so I couldn't do it in Spanish for my in-laws to understand what I was saying. It reads Spanish, but is a computer. It's a machine learning, machine speaking Spanish. Like, for example, Dunieski conoció a Janet 20 años atrás. But it's very awful. It's a bad Spanish, super bad. So far, it only supports English. I don't think it supports any other language. Even though sometimes you tell Alexa, sing for me in French, and it does in French. But it's a short song. Okay. Do you know any other language that Alexa supports?
No.
I think is, let me see here. Developer site for Alexa building Alexa skill building.
How did you know? You just tried it out randomly, or did you follow documentation to develop?
No, I was studying for the developer, and then one of the, it was not part of the exam, but the guy just gave it as a bonus.
Okay.
Yeah. It's Amazon developer. I think that's the website. Amazon developer, Alexa skill kit. And I think that you have to log in somewhere here. This is my website. Okay, I'm already logged in. So I guess to get started here. And then I don't remember well, but it's somewhere here. Okay.
Okay.
So this is the website. It's a developer.amazon.com. And you have to have Alexa, right? So if you have Alexa, you can do it. It's super easy. It's just you create the questions and create the text that Alexa is going to read. And if you guys don't understand this, you can watch a tutorial on YouTube, and it's going to be easy. I think there should be like hundreds of videos about this, because this is very popular.
Yeah.
And sometimes people will not believe you. Are you able to get an Alexa skill? Of course I am. I just need to have access to this website. That's it. Okay. So machine learning, right? And that's what Alexa uses to, to recognize your voice. And also that's what Apple is using to recognize your face, right? When you have face recognition, right? And then provides a cloud-based environment used to develop, train, test, deploy, manage, and track machine learning models. I was thinking about getting this certification, but it's a little painful. Okay, some people, they have studied for this certification, and they say that it's like learning Chinese. But it's just services. What you have to do is become familiar with the services. That's it. For example, in AWS, there's a service called SageMaker. SageMaker That's the one that works with machine learning. You have to understand how to work with it, and that's it. It's like when you create a virtual machine, you learn how to create a virtual machine and how to work with VMs, right? If you want to create a resource group, you know how to work with resource groups. If you want to know how to create artificial intelligence or something like that, you have to know how to work with the services that work with that. Simple. The services have been created for you. You just have to become familiar with it. All right? So there's something called Azure Machine Learning Studio. It's a collaborative drag and drop that makes it easier. When there's a drag and drop, it becomes easier, right? And it's a visual workspace where you can build, test, and deploy machine learning solutions without needing to write code. Do we have to be developers? No, we don't. We don't need to write any code, right? You just have to understand what you're doing. That's it, right? So I'm gonna paste here in the chat some pages that have to do with this that we are saying right now. Okay. I have no idea, Alva. I don't know what Klingon is. Is that a language? Is that even a language? I don't know what that is. Esperanto, I don't think that Alexa supports Esperanto yet. We will have to find that. If it doesn't speak Spanish, I don't think it's going to speak Esperanto. Funny. Okay.
So the difference between learning service and learning studio is service is writing code, and the studio is not writing code. That's the difference.
The studio is a workspace where after you create the solutions with the Azure Machine Learning Service, right? Then that solution that you create with that service, you can deploy it in the workspace.
Okay.
Those solutions, right? Now, well, I don't watch Star Trek. That's why I didn't know about that Klingon language. Do you guys like those movies, Star Trek? I don't like that. Too much science fiction. However, I like Avengers. I love Avengers. I saw all the, my wife and I, we had to like watch all the movies from the beginning. The first Avenger, Captain America, I watched in a sequence all of them until the final game, which is the last movie of the Avengers where Iron Man is killed, and also Captain America becomes very old, you know. Which it's like 21 movies, so we watch them one after the other. I like the Avengers, but no Star Trek or Star Wars. I don't like that. Maybe you do, guys, but I don't. Okay. So the serviceless computing, serviceless. Okay. Serviceless, we don't need a server, right? As the word says, we don't need a server. It's just it's services that don't require a server. Now, you may be wondering, Professor, if it doesn't have a server, how does it run? Okay. Actually, it has a server, but you don't have to deal with it. That's why it's called serverless, because it's a solution. It's computing. You don't have to manage any servers. You don't have to patch any operating system. You don't have to do anything. It's already done for you. It's managed for you. That's why it's serverless. Behind the scenes, there's a server, a physical server, but you don't have to worry about that, right? That's why it's serverless. If you have a virtual machine, that's not serverless because you have a server, right? So you have to work with that server. You have to secure that server. But when you have functions, for example, that are serverless, you don't have to worry about any servers. What you have to do is just upload the code or write the code, and then just watch it run. It will run for you. Okay, as simple as that. So Azure Functions, just remember Lambda in AWS is the same thing. It's code running your service and not the underlying platform or infrastructure. So you don't have to worry about any servers infrastructure as a code. You don't, not as a code, as a service. You don't have to worry about that. It creates the infrastructure based on an event. So there has to be an event. Like for example, someone makes a change to a container, and then that will trigger an event, and then Azure functions will run and notify someone that someone made a change to a container. So that's how it works. Also, we have Logic Apps. It's a cloud service that helps you automate and orchestrate tasks, business processes, and workflows when you need to integrate app data systems and services. This is very similar to step functions in AWS. Similar, okay? It's when you have to orchestrate workflows, different steps, right? Different tasks and business processes. So for that, we have Logic Apps. And then you have Azure Event Grid, which is a fully managed intelligent event routing service that uses a publish-subscribe model for uniform event consumption. And that looks like something that is known in AWS as SNS. Remember SNS, Simple Notification Service? That is a publish-subscribe. You have to subscribe to a service, and then you publish the message, right? Very similar. Okay, so let me paste the links that have to do with this. Okay. Okay. There you go. Next one is DevOps, and DevOps is just development and operations. Okay, so DevOps is a culture, it's a mindset, it's an idea that just bridges the gap between development and operation, and it provides development collaboration tools, including pipelines, Git repositories, Kanban boards, and extensive automated and cloud-based load testing. So when you hear DevOps, you just think real quick about automation, right? Now, this is a collaboration thing. They use, I don't know if you guys have heard about GitHub and services like that. That's a collaboration tool where people can work together. They can have a pipeline where you get the code from GitHub, and then you build the code, and then you deploy the code. So you can create pipelines like that. They use a lot of standard automated situations, and also load testing. They also have something called Azure Dev Test Lab, which allows you to quickly create environments in Azure while minimizing waste and controlling cost. So if you want to save money, Azure Dev Test Labs is the way to go, and that's in DevOps, okay? DevOps engineer, guys, they make a lot of money. They make a lot of money. We're talking about almost $200,000. Okay? So if you want to...
Damn, that's a lot of money.
Yes. If you want to aim high in the cloud, try to be a DevOps engineer. If you're seasoned, I've seen salaries of $250,000, $250,000 as a DevOps engineer. But when they ask for experience, we're talking about 10, 15 years, probably. All right. So Azure App Services quickly and easily build web and mobile apps for any platform or device. Multiple languages, okay? Multiple languages, DevOps optimization, global scale with high availability, connection to SaaS, platforms and on-premises data, security and compliance, Visual Studio integration, API and mobile features, and services code. So you can do all that with Azure App Services. Okay. So these are the Azure management tools. Have we been using the portal? Yes, we have. Have we used the PowerShell? Yes, we have. Have we used the Azure command line interface, Azure CLI? Yes, we have. Have we used the Azure Cloud Shell? Yes, we have. Have we used the Azure mobile app? No, we haven't. And have we used the Azure REST API? No, we haven't. But this is the list of some of the management tools of Azure. Okay, so just try to remember the two that we haven't seen so far, right? And the other four, we've seen them, right? So simple. If they ask you about the management tools, now you know what to say. We have another guy called Azure Advisor, trusted advisor in AWS. Okay, Azure Advisor. It gives a recommendation about high availability, security, performance, cost optimization. Okay, you can see that. You can have an overview of your services, and then you can see what recommendations they're going to give you. What it would do, it would analyze whatever the resources you have deployed, and based on that, it would give you recommendations on ways how to improve the availability, security, performance, and cost, right? It will give you proactive, actionable, and personalized best practice recommendations. Improve the performance, security, and availability of your resources, and identify opportunity to reduce your Azure costs. In other words, Azure Advisor is your cloud expert. It's the one that's going to help you save money, secure your applications, improve the performance of your application, and make your applications more highly available. Simple as that. So recommendations. When you hear the word recommendations is a key word for the exam. When you hear recommendation, that's Azure Advisor. Okay, don't forget that. Very important. Okay, let me paste the link to the Azure Advisor. There you go. Hey, that's not the link. One moment. Yes, it does. It's the second one. You just put them one next to the other. Okay. And that's it, guy. That's it. That's it for the slides today. Okay. Now, we're not going to go over the important points. Okay. I recommend. I believe that you should have gotten the important points. Can you check your email and let me know if you got the important points, please? Yes, no, maybe.
I'm checking. It would have come in just now.
Let me check.
No, I have module 2. What is it? What's the name of it?
Important points.
Important points.
Let me see here. Let me see.
Not yet.
What?
Not yet.
Not yet, huh?
No, I don't see it.
No, I don't have anything either.
No, I just have what you sent earlier before the class for module.
Okay, important points is gonna come at 9 p.m. Okay, so real quick, because we're gonna have a quiz on 9 a.m., a quiz of today's PowerPoint. I want someone to real quick, open the CLI and create a user. Okay, can someone do that real quick? Not a user, a resource group. Can someone create a resource group real quick? Can you share your screen and create a resource group? Can you do that? I want a brave person to do that, not for me, not for them, for the class. Can I have a brave person? No brave person? Do I have to point at someone? Do I have to pick someone?
Please don't call me.
Laris, can you do it? It is valid to check the documentation. Can you do it, Lanis?
You said the CLI?
Yes.
Okay, give me 1 second.
John Paul, you want to do it? Guys, I'm not going to do it. Okay. Okay. Roger, you want to do it? Me neither, Brian.
I'll try it, I guess. See how it goes. Where is
Okay,
my-
let's do it.
You gotta share your screen
No, first I gotta bring up the CLI.
so the rest of us can see.
Yeah.
Is that Alba? Is that from the Hunger Games? Okay, can you explain, Roger, why you do that?
Oh, that's how I get to my command line.
By the way, Roger is using the Linux subsystem in Windows.
Crap. Delete this. Hey,
Just put in one line. It's a short command. Just hit enter
oops.
or Control C probably.
Oh.
Okay, just put in one line. I'll give it a different name. I guess you have that
Yeah, I
already
will.
here. You might get an error, but just continue.
Group, create.
And let's see what happens.
Oops.
You're missing the location
Oh,
parameter,
location.
location arguments.
Was it East US?
Yes.
You don't have to put the comma before the east.
No comma. Okay, I think that region doesn't exist.
Oh, too many U's.
Try that.
Password expiration.
Try to log in again.
Ay, ay, ay. Pop up next screen. Huh? Did I forget my password? Okay, that's better. Woohoo! Actually worked. Did I lose
Can
you
you
guys?
list all the groups that you have to confirm?
Uh,
Check if the one that you create is there.
yep, it's there. Name my new resource group. There.
Can you now to the portal?
Okay, hang on. I have it open somewhere.
Can you go to the portal?
I'm trying to get it. It's just not letting me log into my portal for some reason. Hang on.
Can someone run this command and show me the portal? Possible?
There we go.
Good. Can you go to where that resource group is?
There it is.
Okay, guys, I want now, can you show me the users, please? The users?
I don't think I have too many users on my
Doesn't matter, as long as you have two.
deleted everything because it's almost charging me
Okay,
money.
can you create another one?
Yeah.
Can you create, just give it a name, any name. ABC, okay. That's a good name.
Oops. Why does it say first name and then first name again?
Yeah, that's the way it is. Just give it a, okay. So A, B, C, D, E, F, E, G, whatever. Okay, just let it generate the password and then create. Create. All right, so I want you to go to resource group again. go in my new resource group. Guys, can someone assign a role here? Can someone assign a reader role to that resource group? Can someone do that? If I want now ABCD to have a reader role in this particular resource group, how do I do that?
We did that in the first class, didn't we? Or the second class.
Don't do it. Don't do it, Roger.
Oh,
Go to the roles.
How do we do it?
In this list, you can go to the roles.
Add a tag. I don't know. A policy? No. Access control.
Well, you're the one deciding. Okay, you're the ones deciding. Come on, the rest of the class, we need some help here.
Access control.
Okay, Roger.
No.
Your daughter's telling you. What do you do?
A, B, C, D.
Be careful, don't mess up that. You're not creating anything.
You're not creating it, right? Search by name or email. His name is ABCD, right?
Yeah.
No,
No.
not gonna find anything. You haven't
Maybe.
assigned to.
AB is the name, CD is the last name.
Oh, sorry.
Role. Select all. That's fine. That's fine.
Does anyone have an idea before I tell them the answer?
Click on roles. I don't know. Check act. I don't know. Deny.
You have to click on roles and read only.
No, that's not an option. I think maybe didn't.
Guys, what is the add button for?
To add the
Add a row.
Oh,
Lock.
okay.
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 Add role assignment.
Okay. What kind of role are you gonna add?
Reader.
You're gonna have the reader roles.
And
assign
then
access roles.
no, that's fine. That's fine. Okay. Now look for the
It
user.
says AD user.
Just click. It's
It's
right,
right there.
Yeah.
Click user,
And
and
save.
then save it. There you go. Check access now. Check access. Okay. Look for the user.
Under the drop down, yeah.
Okay. Right in. Okay. Second box, not that one. The other box.
Go under.
Yep. Okay. Search by name. Search by name. The other box. Okay.
I think you need to user.
Now, just click on role assignment. Role assignment. That's the other tab.
The tab next to check access.
You see down there?
Yeah.
There's a reader.
Yep. So you did it. That's it.
So whatever you put inside that resource, you can view everything, but you cannot manage access.
Oh, okay.
Just hover over the little circle that has the eye inside. You see, you can view everything, but you cannot make any changes.
Right. Got it.
Okay.
Yep.
So if you sign in as ABCD, right? Because now you're signed in as administrator. If you log out and you log in back in with this user, you can read everything in that resource group, but you cannot make any changes because you have simply a reader role.
Right, only read access. Got it.
Guys, you should have gotten an email from me that has a test, a quiz.
Not yet.
Not yet.
Let's wait. I see Roger just gave you save away. You haven't done the measure up thing.
No, I did not.
Oh, you haven't seen any of the go extra mile thing either.
I have, but what I did was I put it as unread so I can go back to it.
Okay, not a problem. I understand. Okay, so guys, I see here that it was already
Sent?
yeah, it was sent already. So can you refresh there?
There we go.
There you go.
Yep.
There you go. So take that quiz, guys. Take that quiz. You can stop sharing if you want to, Roger.
Okay.
And Ciara, we're taking quiz for day 4. You should have gotten an email with the access.